Hi, welcome to Module 7 of Lecture 11. This is the fourth and last lecture detailing methods to solve systems of linear equations. So say, if at this point you're like, I'm good, I've had enough of this stuff, show me 3 different ones, I found one I liked, skip this. It's not that important. It's just yet another way of solving systems of linear equations. In this case, it's actually fairly restrictive as well, in that it applies to square matrices again. But if you're looking for a different one and you don't like inverting matrices, but you do like matrices, here's a good one for you. This one's called Cramer's rule. And it again uses the matrix formula, the matrix representation of the system, that x equals b. But instead of inverting a to solve it, you use a particular rule which says that the ith element of the column vector x, the solution for that is going to equal the determinant of the matrix Bi, which I'll get to in a second, divided by the determinant of A. Why that is going to relate to a bunch of things involving the determinant. Not very important for our purposes, so we'll skip that. What is important is what Bi is. Bi is a matrix obtained by taking the matrix A and replacing the ith column with the B column vector. That's it. So let's make up an example now and be done with this. I'm not usually keen about this if you can't tell right now, but still, to be complete, here you go. B. Let's do B last. Obviously, let's pick the same answers as before. x1 equals 1. x2, I'm using x1, x2, and x3 instead of y to be consistent, y and z to be consistent with this notation. There you go. We'll pick a new equation, and I'll make it a matrix immediately. Gotta write small because there's a lot of determinants here. So let's pick one. Let's make it similarly fun to last time. Where's it? 1, 0, 1, 1, 1, 0, 0, 1, 1. That worked well, right? Let's do that one again. Okay. What was this again? This was 4 and 3 and 5. There we go. We know this works. Here's our A. Down here. What's B1? Well, B1 is A replacing the first column with B. So we replace the first column with B. And B2 is equal to A with the second column replaced by B. And B3 is equal to A again with the third column replaced by B. There you go. Okay, and I blocked that. Okay, so there we go. So now we have the determinant of 4 matrices. Now luckily we did the same example in the previous module. So it turns out, and you can go back and check that one out if you want, it turns out the determinant of A equals 2. So we're done there. How about B? B1. Determinant of B1 is what? Well, let's expand, not using that first column, but rather the last column. Why not? So expand using the last column. Oh, we can cross them out too because, all right. So the last column, so here's the first one. So that's me 1 times 4, 1 times 4 is 4, minus 1 times 5 is 5. So 4 minus 5 is negative 1. So 1 times negative 1. Next one is 0, so that's plus 0, who cares? And the last one is 1 again. Cross these out. You get 4 times 1 is 4. Minus 5 times 0 is 0. Oh, sorry. Minus 3 times 0 is 0. So that's 0. So it's 4 minus 0, or 4. So you have negative 1 plus 4 equals, and I made a mistake there somewhere. Try again. Oh, sorry. I apologize. This was, again, a mistake from last time, remember. So the first one was not 4. It was 3 times 1 minus 5 times 1 is negative 2. 3 minus 5 is negative 2, not negative 1. So that's 4 minus 2 equals 2. There's the determinant of B1. B2. Again, let's do the last column to expand around. I'll do it a little more carefully this time, so get rid of these two things. You get 5 times 1 is 5, minus 3 times 0 is 0. That's going to be 5. The second one is 0. The next one, so that's 1 times 5. I apologize. Last one is 1 times the determinant. So this is these two we get rid of. 3 times 1 is 3. Minus 4 times 1 is 4. That's minus 1. You get 5 minus 1 equals 4. And finally, B3 determinant. Now let's expand around the first column. So that's 1 times, get rid of the first row in the first column. You have 5 minus 3 is 2. Now the second one, the sign flips because it's it's plus 1 times negative 1 to the 2 plus 1. That's negative 1. Get rid of the second row, first column. You get 5 times 0 is 0. Minus 4 is negative 4. Plus 0, because the last one is 0 down here. That equals negative 1 times negative 4 is 4, plus 2 is 6. And lo and behold, you have x1 equals 2 over 2, which is 1. x2 equals 4 over 2 is 2. And x3 equals 6 over 2, which is 3, and we're done. And that was the shortest one yet because we've already done this example. It works out just fine, and you see how to do it. And again, that was really too fast. I've made a mistake because it was so fast. When you do it by yourself, it's highly advised to go through and work with the example on your own and make sure you can take these determinants. It's a good practice and it'll serve you well when you use this stuff much more frequently later on. But as far as I'm concerned, this is the end of this module and the end of our modules solving linear equations. Having made it through all this, we're now going to use the stuff we learned in this lecture so far and see how it applies to concrete examples in stats and game theory. Thank you very much.